Hello, this is a short 5-minute presentation just reviewing the dot product, what it is and what it is used for. So mathematically, when we talk about the dot product, specifically refers to two vectors. And we have vectors A and B, and in the case of the class, remember this means vector. It could be F1 and F2. Okay? So whenever we have the notation as vector, what we do is vector F1 dot F2 would be the magnitude of F1 times the magnitude of F2 times the cosine of theta, theta being the angle between the two vectors. But again, this is the generic equation because it applies to any vector. So also F1 dot F2 or A dot B refers to this expression where you have AXI, that's your vector A, AYJ, ACK dot BX, because remember this is the vector notation. So this is vector A and this is vector B. So the vector notation. So then it would be AX times BX plus AY times BY plus AC times BC. And the result of this is a number. Okay? So this, what it does, it gives you a magnitude. Okay? And this number that you obtain here also equals the magnitude of A times the magnitude of B times cosine of theta. Okay, so this is the mathematical formulation. So this is what I just said. Okay, so mathematically that's it. Now, what does it mean, and how do we use the dot product in statistics? Well, the dot product, we use it to determine the components of a vector that are parallel or perpendicular to any line. So I put this at an angle so you understand the significance of this concept and how we can use it. So the dot vector is the dot product is the dot product between two vectors, two any vectors. Okay, so here we have vector A, and then now we have a unit vector UA. So what the dot product does is that whenever you have this unit vector and you have the vector A, you can find the projection of that vector on any axis. Remember that we did the projections on axis X and axis Y? Well, now we can do that projection on any axis along any line. So this would be line AA. So now the definition is that in this case, the magnitude, so remember this gives you the magnitude of the vector that is parallel to that line AA, and this is magnitude. It's going to be equal to the vector A times the magnitude of the vector along line A times cosine of alpha. Same thing, but now you know that the magnitude of the unit vector here is 1, right? The bottom line is that then this, as I mentioned earlier, would be this expression here. So let me just put it into context for the forces, how we use it in statics here. Let me change the pointer options. So if this was a force, then I can obtain a unit vector along any line, and for this I use a position vector. Okay? So the way we do it in statics is that you obtain a unit vector from a position vector in the direction that you want to find the projection of the vector. So then the projection, the vector the magnitude of the vector along that line AA, that projection, remember this would be the projection, so this would be FA, is equal to the magnitude of that vector, of course the magnitude of the unit vector, cosine of zeta, whatever angle it is, but the significance then here is that you have fx uax plus fy uay plus fz uaz. Now remember that the magnitude of the vector is 1, but these numbers are not necessarily 1. Okay? So basically what we do is, that way we find this magnitude using this equation, and then if you don't have the angle, you can calculate the angle. So depending on the information that you have, if you have the angle or not, then those are the equations you have to formulate. Okay? So this expression is very important. This is the main use of the projection of a vector using the dot product. Then we can find the component that is, in this case, this is the parallel component. So you can find the one that's perpendicular. Okay? So arranging this, whenever we talk about the magnitude, remember these are magnitudes here. Okay? You can find the magnitude, and this comes from, this is the vector down here. Okay? And this is the vector. Okay? So I hope this clarifies those questions. And let me just go real quickly over this example that was discussed in class. So what we did was, number 1, find the position vector from A to 0, and from that obtain the unit vector by dividing that vector by its magnitude. Okay, so once you have the unit vector, then the component of the force along line AO, the magnitude of course, would be then, we can do it in two ways, right? We can say then that it's Fx UA0x plus Fy UA0y plus Fz UA0z. That is the magnitude. Okay? So that was the question, the vector on the line, the magnitude of the projection along line A0. So basically that's the procedure. Again, here is the same situation. It asks for the projection of this 300 Newton force along the line OA. So what we find is the position vector now is from 0 to A. You need to find that projection vector and then obtain your unit vector, which would be ROA divided by its magnitude. Okay? So you'll obtain something in the form of a 0 AX I plus 0 A YJ plus U 0 A ZK. That's what you'll obtain. So then the projection of the force, and then in this specific case, you need to also find the vector for the force, because you need, this is the magnitude of the force, but you need the vector of the force, and for that you use the multiplication. So you look for the magnitude of the force multiplied by a unit vector in the direction of the force. Okay, so you'll have a unit vector, so this is not a dot product, so then you'll obtain this force vector and look at the example that was discussed in class, and then once you have the force vector, then the force vector dot U, in this case 0A, would give me then that magnitude of the force along the line 0A. Okay? Remember that this kind of examples have to do with a structure the same way that a body. If you pull my arm, I will have some stresses and some forces on my back, for example. So this is the way of finding that how that force is projected onto other components of the system, in this case my body. So